This lesson is part 1 of section 6.1, solving one-step inequalities. So today what we're going to do is solve and graph one-step inequalities. Alright, so let's go ahead and start filling out this table. So the word up here on the top left of the bar here says inequality, and underneath is listed a bunch of inequalities. Now what we're going to do is describe that in words. So right here we have x is less than 2. That's the less than symbol. So this means x is less than 2. Now as a graph, what we're going to do, on a number line, we're going to place the number 2. We're also going to place the number 0. Okay, I'm going to put the 0 left of the 2 because obviously 0 is less than 2. And then I'm going to graph with an open circle for this less than, okay? And I'm going to shade to the left. These are all the numbers that are less than 2. Okay, so another way of writing this is all real numbers less than 2. And if you look, the way we shaded, right, we shaded to the left here, is the same way that this arrow here is pointing. It's actually facing to the left. So we're going to shade to the left. Now for the next example, we have a is greater than -2. So we are going to write that out in words as a is greater than -2. So we're going to plot -2 on a number line with an open circle. This time we're going to put 0 to the right of -2, about right here. Let me erase right there. Then I'm going to shade to the right. These are all numbers that are greater than -2. So I'm shading in the part that makes this inequality true. These are all the real numbers that are greater than -2. So again, in words, we can write all real numbers greater than -2. Alright, our next inequality here has a less than or equal to symbol. So you probably remember a lot of these symbols. We're just going to review them real quick. So this is saying z is less than or equal to 1. So when it has the bar underneath, that's when we get the word equal in there. Alright, so we're going to place a 1 on the number line, and we're going to place 0 to the left, because 0 is less than 1. And we're going to, this time, when we make our circle, we're actually going to fill it in. We're going to call that a closed circle on the 1, and then we're going to shade to the left. That's the direction that this arrow here is pointing, right? So we're shading to the left. Now for the last example, the inequality is d is greater than or equal to 0. So greater than or equal to 0, let's just place 0 here. This time we're not going to have another number because 0 is usually our reference point, so we're just going to leave 0 right there. And I'm going to have another closed circle on 0. This time I'm going to shade to the right. These are all numbers that are greater than or equal to 0. Okay, so this is showing you any number greater than or equal to 0. Alright, so let's recap now the big idea of this part of the lesson. When we have a less than symbol or a greater than symbol, when we graph, we're going to have to make sure that we have an open circle. Okay, so you can see that example right up here. Here we have an open circle, here we had an open circle. Okay, now when we have a less than or equal to symbol, so this is a less than or equal to symbol, it's got the bar underneath, or a greater than or equal to symbol, like that, then we're going to have a closed circle, meaning it's shaded in just like that. So here we can see that in the last two examples here. This was the less than or equal to, here is the greater than or equal to. We have closed circles on both of those numbers. Alright, now in the last part of this lesson, we're going to focus on what it means to solve an equation versus solving an inequality. So on the left here we have an equation. And the reason why we have an equation is because I see an equal sign here. On the right, I have an inequality because instead of an equal sign, I have a different symbol. I have a greater than or equal to symbol. So that's the basic difference between an equation and an inequality. Now from there, the represented solution is a little different, but we solve it actually almost the same exact way. So right here, if I want to get x alone, we know we have to add 4 on both sides. So I'm going to add 4 on both sides. I'm left with x will equal 5. Now what this is saying is that the only solution to this original equation is 5. So x can only be replaced by 5 in order for this statement to be true. If I plug in 5, I get 5 minus 4, that equals 1. That checks off, right? 1 is equal to 1. So if I were to graph this on a number line, I would place the number 5 here on a number line. I could even put 0 here. This time I'm just going to have a closed circle on 5. There are no other numbers that work in this equation. It's just showing that one number 5 that works. Okay. Now when we solve an inequality, we actually use the exact same step over here. We're going to add 4 and get x alone. So I'm going to add 4 on both sides, and I'm left with x is greater than or equal to 5. Now this is a much different answer than my answer was over here. This is saying only x can equal 5 to work in this equation. This is saying that any real number, as long as it's greater than or equal to 5, will work inside this original equation. So that means I can plug in a number like 10, because 10 is greater than 5, right? So if I try to plug in 10 here, I get 10 minus 4. Is that greater than or equal to 1? Yep, absolutely. That still checks off. As long as I plug in any number greater than or equal to 5, it will work. So this time, when I graph this, I'm going to have the 5 here. I'm going to place a 0 to the left, and I'm going to put a closed circle here on the 5, very similar to what we just did right here, except for this time I'm going to shade all of the possible solutions. These are going to be all numbers that are greater than or equal to 5. So again, see how that arrow is pointing to the right? I can shade to the right to show x is greater than or equal to 5. So this has many solutions, right? Many solutions here, which we can say an infinite number of solutions. Whereas over here, we only had one unique solution to this equation. It was only x equal to 5. All right, that's the end of the lesson. We are going to do a lot more solving tomorrow in class, so good job. See you tomorrow.